We are seeing module 5 field effect transistors under analog electronic circuit. What is FET? Field effect transistor. We call it as, so we have two types of transistors, one is BJT and the other one is FET. BJT is a current control device, whereas FET is a voltage control device. So there are of two types. One is called metal oxide semiconductor field effect transistor, we call it as MOSFET, and the other one is called junction FET. MOSFET is also called as insulated gate FET or IGFET. So it is compact in size, simple manufacturing processes, and it has a low power consumption, and it is widely used in VLSI circuits. Defining the structure of a MOSFET, this is an N-type MOSFET wherein the source and drains are of N-type materials, and P-type semiconductor substrate. Always substrate and substrate, source and drain should be of opposite type materials. So here I have one more thing called gate. Under that a channel formation will be formed. So we will be having the current flow from source to drain through the channel as such. For normal operation, it need to create a conducting channel between the source and drain once we apply the gate to source voltage. So we can see here, this is called this is the figure for the N-type MOSFET. An N channel can be induced at the top. We can see the channel induction here, induced at the top of the substrate beneath the gate by applying a positive voltage to the gate. So this is positive external voltage that is applied, VGS. The channel is an inversion layer. So this is nothing but a inversion layer, we can call it as. This is the semiconductor, that is SiO2 layer, and this is the gate electrode to which we will be applying the external voltage as such. The value of VGS at which a sufficient number of mobile electrons accumulate to form a conducting channel is called as the threshold voltage VT. So it has to cross the threshold voltage. So now the channel length also matters. So we need to specify what should be the channel length for the MOSFET as such. So channel length, width and its thickness are mentioned here. So this would be the cross-sectional view of a MOSFET. Under the classification of MOSFET, we have say two types. One is MOSFET and one is JFET. Under MOSFET you have two types. One is N channel and another one is P channel. Under N channel we have two types. One is enhancement type and the other one is depletion type. Similarly, under P channel also we have enhancement type and depletion type. So here an NMOS transistor should have the gate to source voltage should be greater than the threshold voltage, and with the small drain to source voltage being applied, the channel will be formed. The channel depth is uniform and the device acts as a resistance. The channel conductance is proportional to effective voltage or excess gate voltage. So the drain current is proportional to VGS minus VT, which is called as VDS. So this is a graph which shows the VDS versus ID versus VDS. ID is always in milliamp and VDS will always be in millivolt. So as the VDS increases, we can see what happens to VGS. So VGS starts increasing, linearly increasing. The induced channel acquires a tapered shape